The new type dry process cement production line is designed and contracted by Jiangsu Pengfei Group Company Limited. It's a modern cement production line, based on raw meal pre-homogenization and rotary kiln calcination, featuring suspension preheating and pre-calciner technology at its core, which features high production capacity, a high degree of automation, superior product quality, low specific energy consumption, and good environmental friendliness. Currently, our group possesses strong technical expertise and extensive construction experience in the field of EPC turnkey projects for new type dry process cement production lines with daily capacities of 2,500 tons, 3,000 tons, 5,000 tons, 6,000 tons, 8,000 tons, and 10,000 tons. Jiangsu Pengfei Group provides comprehensive one-stop services including raw material analysis, exploration and site selection, process design, civil construction, equipment supply, installation and commissioning, quality and output guarantee, personnel training, and technical support. It ensures that upon completion and operation, all technical indicators of the production line will reach internationally advanced standards. The main process include crushing, pre-homogenization, raw meal preparation, raw meal homogenization, coal grinding, preheating and pre-calciner, rotary kiln, clinker cooling, transportation and storage, cement grinding, cement storage and packing, waste heat power generation, central control system. The first step in producing cement is taking raw materials. The raw materials are obtained through processes such as stripping and drilling and blasting from the mine and then crushed. After entering the crushing process, the large limestone is fed into the hammer crusher by the heavy-duty plate feeder. At this time, large pieces of limestone are broken into small particles of less than 100 millimeters, which fall onto the long-distance rubber belt conveyor and transported to the main plant area of the cement plant. The small limestone particles, entering the factory area, first go through the pre-homogenization process section. With the assistance of the stacker and reclaimer, the pre-homogenization operation of the limestone raw materials is completed to prevent fluctuations in raw material indicators and ensure the stability of clinker quality. After completing the pre-homogenization process, various raw materials are proportioned and automatically controlled by the central control system before entering the raw meal preparing process. First, each type of raw material is separately discharged into its respective storage bin at the raw material batching station. After being weighed by the electronic scales at the lower part of the bins, the various auxiliary materials and limestone particles are transported to the vertical raw mill according to the optimal proportioning ratio. Vertical roller mill is the core equipment of this process. It can simultaneously complete the tasks of grinding, drying, classing, and conveying. It has the advantages of high grinding efficiency, large production capacity, low unit power consumption, and low metal wear. After entering the vertical mill through the feeding port, the raw material falls into the center of the grinding table. Under the action of centrifugal force, the material moves uniformly towards the edge of the grinding disc and is crushed by multiple rolling of the grinding roller. The crushed raw materials continue to move towards the edge of the grinding disc until they are blown upwards by the high-speed hot air at the edge of the wind ring. When the mineral powder in the airflow passes through the upper separator, qualified cement raw meal is out of mill together with the airflow. The raw materials with unqualified particle size fall back from the cone hopper to the center of the grinding disc for re-grinding. At the edge of the grinding table, a small quantity of oversized raw meal particles remains, as they cannot be lifted by the rising air stream. These oversized raw meal particles exit the mill through the rejects port beneath the grinding table and are then sent back to the mill by conveying equipment for further grinding. Finally, the cement raw materials are collected by the dust collection system and transported to the raw material homogenization process section to stabilize the composition of the raw materials entering the kiln and ensure the quality of clinker burning. At the same time, in the coal grinding process, large coal particles are fed into the vertical coal mill. Take the independent 3-roller vertical coal mill, commonly used in a 5,000 tons per day, new type dry process cement production line, as an example. The mill's grinding rollers are rotated by the grinding table, crushing the coal lumps that move from the center to the edge of the table into fine coal powder. The pulverized coal that moves to the outer edge of the grinding table is dried by high-speed hot air and blown up to the classifier at the upper part of the mill. The fine pulverized coal exits the mill and is then captured by the dust collection system. Then, after flow stabilization and metering, it is respectively sent to the pre-calciner and the rotary kiln for combustion. The coarse coal particles drop back onto the grinding table for further grinding. The preheating and pre-decomposing process is one of the core technologies of the new dry process cement production line. The collaborative work of suspension preheater, pre-calciner, and rotary kiln can achieve efficient calcination of raw materials and full utilization of heat. The preheater and pre-calciner can increase the heating efficiency of raw materials by more than 85%, and the decomposition rate of calcium carbonate exceeds 90%, saving more than 30% energy compared to traditional processes. The main components of the preheater and pre-calciner are connection equipments at the kiln inlet of the rotary kiln, pre-calciner, the fifth stage cyclones, the fourth stage cyclones, the third stage cyclones, the second stage cyclones, the first stage cyclones, powder conveying pipelines, hot AIR and powder conveying pipelines of pre-calciner, feeding bucket elevator, exhaust pipe for high temperature exhaust gas. The technical core of preheating and pre-decomposing process is guides the high temperature airflow to move from bottom to top, while directing the raw meal fine powder to move from top to bottom. The high temperature hot air heats the fine raw meal powder stage by stage, thereby completing the pre-decomposition of carbonates. The motion path of high temperature airflow is firstly, the secondary air at approximately 1100 degrees Celsius in the inlet of the rotary kiln, and the tertiary air at 850 to 950 degrees Celsius discharged from the grate cooler enter the pre-calciner. The high temperature airflow in the pre-calciner moves rapidly from bottom to top, at which point the hot air temperature inside the pre-calciner is approximately 900 degrees Celsius. The hot air in the pre-calciner enters the fifth stage suspension preheater through the air duct. The hot air temperature inside the fifth stage cyclones is about 860 degrees Celsius. High-speed hot air flows upwards and enters the fourth stage cyclones. The hot air temperature inside the fourth stage cyclones is about 750 degrees Celsius. High-speed hot air flows upwards and enters the third stage cyclones. The hot air temperature inside the third stage cyclones is about 625 degrees Celsius. The high-speed hot air continues to flow upwards and enters the second stage cyclones. The hot air temperature inside the second stage cyclones is about 475 degrees Celsius. The high-speed hot air flows upwards and enters the first stage cyclones. The hot air temperature inside the first stage cyclones is about 305 degrees Celsius. Finally, the hot air mixed with some powder enters the large high-temperature dust collector along the high-temperature exhaust gas discharge pipe. The flow path of the fine raw meal powder is: first, the raw meal fine powder in the raw meal homogenizing silo is lifted by a bucket elevator to the very top of the 5-stage cyclone preheater. Through equipment such as feed pipes, airlock valves, and distribution valves, the raw meal is fed in equal amounts into the 2 symmetrical first-stage suspension cyclones. Raw meal fine powder enters through the air inlet pipe of the first-stage cyclones and is dispersed by the rapidly ascending hot air flow, then blown into the first-stage cyclones. At this point, the raw meal powder is in a suspended state, and the heated surface area reaches its maximum. It can efficiently exchange heat with the hot air inside the suspension preheater and quickly raise the temperature of the raw meal powder for preheating and decomposition. Subsequently, the raw meal powder is fed into the second stage cyclones through the discharge pipeline at the lower part of the first stage cyclones. After the temperature of the raw meal powder is further increased, it is fed into the third stage cyclones through the lower discharge pipeline. The temperature of the raw meal powder increases again, and then continues to move downwards, entering the fourth stage cyclones. The heated raw meal powder is sent into the pre-decomposition kiln through the Y-shaped discharge pipe at the lower part of the fourth stage cyclone. After entering the pre-decomposition furnace, the high-temperature raw meal powder is suspended in the furnace and undergoes sufficient heat exchange with the heat generated by the combustion of the injected coal powder, thereby pre-decomposing most of the carbonates. There are multiple coal injection devices inside the pre-calciner. The pulverized coal is mixed with air and injected into the pre-calciner, where it heats the material inside the kiln together with the hot air from the kiln hood. Driven by the high-speed hot air, it moves upward and enters the fifth stage suspension preheater via the Y-shaped outlet at the top. At this point, over 92% of the carbonates have been decomposed. Finally, the material enters the feed end of the rotary kiln through the discharge pipe at the lower part, beginning the rotary kiln calcination process. The application of suspension preheating and pre-decomposition technology reduces the thermal load of the rotary kiln, significantly increases the production capacity per unit volume of the rotary kiln. After the pre-decomposition process is completed, the material enters the rotary kiln calcination stage. The burning zone of the rotary kiln is the core of the cement production process. The fuels for rotary kiln include coal, natural gas, heavy oil, and others. Our company adopts a multi-channel burner to meet customers' requirements for different fuels, providing the necessary flexibility for their various needs. The Pengfei rotary kiln offers advantages such as stable and reliable continuous operation, low maintenance costs, and easy process control. The raw meal with a high decomposition rate enters the interior of the rotary kiln shell through the kiln inlet. It is heated to a molten state. As the rotary kiln shell rotates, the material is continuously agitated and flows along the inclined kiln shell toward the kiln hood. At this point, the raw material turned into cement clinker like magma. large dust collectors are installed at both the kiln tail and kiln head. They will collect the generated dust to prevent environmental pollution. The cement clinker then drops from the discharge port at the kiln hood into the grate cooler, where it is quickly cooled into high-temperature clinker lumps, marking the start of the clinker cooling stage. The grate cooler employs a large amount of cold air to rapidly quench the hot clinker, and recovers the heated air for further use. The cooled large clinker lumps are crushed into small clinker particles by the crusher located at the discharge end of the grate cooler, and then drop onto the chain bucket conveyor. The clinker is then conveyed to the clinker storage silo, waiting to enter the cement grinding section. In the cement grinding process section, a cement roller press pre-grinding system is used to complete the cement grinding. It features low unit energy consumption, high grinding efficiency, a compact process arrangement, and very little environmental impact. It is a relatively advanced and mature system in the international cement industry. Multiple batching belt scales at the lower part of the cement batching station respectively convey the cement clinker and auxiliary materials such as slag, fly ash, and gypsum to the cement roller press pre-grinding system according to the optimal proportioning ratio. The cement clinker and the auxiliary materials proportioned accordingly are fed into the weighing bin by a rubber belt conveyor. Under the comprehensive control of the central control system, the small particle cement clinker in the steady flow weighing bin is continuously and evenly fed into the roller press below. The roller press is the core equipment of this system. It applies the principle of high-pressure material layer grinding and adopts a unit crushing group working mode to compress and crush cement clinker into cement fine powder less than 2 mm. The interior of cement powder is filled with fine cracks due to compression, greatly improving its grindability. After being squeezed and crushed, the cement fine powder is sent to a V-shaped powder separator for sorting. The coarse cement powder with excessive particle size is returned to the steady flow weighing bin of the roller press through the discharge port at the lower side and re-enters the roller press for re-crushing and grinding. The fine cement powder with small particle size enters the combined cyclone dust collector through the upper pipeline for the second sorting. The cement fine powder that has not reached the fineness standard of cement is conveyed to the double slide shoe cement ball mill for final grinding. The cement powder filled with cracks inside is ground into finished cement by a ball mill. The finished cement is transported into the cement silo by a bucket elevator. Part of the cement are directly loaded into the tank of bulk cement transport vehicles by the automatic loading system at the bottom of the silo. This system is equipped with an automatic calibration function for the loading connection port. It also captures dust produced during truck loading and returns it to the tanker. The whole bulk cement loading process is fully automatic, featuring zero dust emission and zero product loss. Another portion of the cement is packed by rotary packer, then transported out of the factory. During the cement production process, high-temperature gases from the kiln inlet, kiln outlet, and grate cooler are collected uniformly and sent to the waste heat power generation process. The waste heat boiler utilizes these high-temperature gases to generate steam, which drives the turbine to rotate and converts thermal energy into mechanical energy. The central control system for the entire cement production line is responsible for detecting, monitoring, and controlling the entire process of cement production. Through hundreds of sensors and monitors scattered throughout the entire cement production line, the central control system can automatically obtain real-time data on various aspects, such as raw material and coal powder preparation, cement calcination, cement blending, clinker grinding, waste gas treatment, waste heat utilization, and laboratory analysis. Based on these data, workers can adjust production parameters in a timely manner, achieve stable batching, ensure stable cement quality, increase output, and reduce energy consumption. It can enable remote monitoring and control of the production line by operators, enabling the intelligent operation of Pengfei Group's new dry process cement production line. Pengfei Group is committed to providing customers with satisfactory products and high-quality services to the greatest extent, creating maximum economic and social benefits for our clients.